Welcome back to Munro Live, everybody. Today, again, we have Carl and Sue to cover more interior componentry. One of the favorite parts of the Model S Plaid for Sandy and I was this center console. It was phenomenal how it worked. But now we have it all tore down, laid out on the table, and these two are going to walk you through how all of this works and a little bit more insight. Sandy is on vacation today, that's why I'm doing the intro, and I need to do a quick shout out to Sabik. Thank you, Sabik, for supporting our road trip and a little bit of the teardown. We really appreciate that. And here you guys go. Have at it.
Well, thank you very much. So on the center console, it is wrapped almost on all sides by some sort of a decorative surface. You'll have your armrest, you'll have your moving mechanism, you'll have your top trim plate, wrapped side panels. Within all of that decorative surface, you have a very complex mechanism, a strong structural support, and a fiber panel that we will talk about in a minute. The decorative surface is one thing. I don't want to say too much about that being unique or a new design. Real wood grain, very expensive option, but if you bought a Model S, you're paying for it, I guess. On top of a ABS panel, chrome trim, wood panel moving cover, flocked bin, wrapped border around the flocking, nice cup holder, wood grain again, chrome trim, all those nice pretty things, but you can remove all that nice stuff and have something very basic, but then you're still left with a mechanism that's kind of unique.
This mechanism, I know Sandy and Corey were incredibly impressed with it. It is super smooth. The actuation, it's just very light touch, and you get just the right speed actuation. And how they've accomplished that is you can see right here these little tabs that are attached to the back of the door. And as you slide the door, those tabs are on spring. Those tabs are actually leaf springs that are on rollers. And you can see these rollers right here. And it's also a beautiful assembly in that these rollers just drop into this track. So once you have those leaf springs hooked in the front onto these tabs on the door, then you place the springs, they just drop right in. It's like a thread spool from your sewing machine, and you just drop that right in, and those will work forever. That's a gorgeous execution. They also have just a simple pad right here that's soft touch to prevent any BSR. And then these gears, how they facilitated the installation is that you can squeeze the gears in and assemble it, and they pop back out into the tracks. The cup holder is actuated the same way, and you can see the leaf spring tabs here. Again, all of the actuation in here is accomplished the same way. It's by gear rollers in tracks with these rolled up springs attached to the tabs.
So I was trying to look through how this thing actually functions, and we have a two-stage lock. Locking out for the cup holder, locking out for the bin. All right, so how is it locking? That's actually this small little wire tab. As this thing functions, the tab moves from side to side and holds it in its two different lock positions. At first I thought, well, that little wire tab, that's kind of insignificant. Is that really going to work? But if you really think about what kind of a force this thing is under, it's just enough spring force to overcome it to lock it in place. So it does work. However, there is one thing that bugs me, and I don't know this. I can see no function that serves.
Now, I have a sneaking suspicion about the function on this. So let's say you're driving down the road and you hit something. You don't want all the stuff in your cup holder and in your console bin to fly out and just come flying around the cabin. And my sneaking suspicion here is that this
is an inertial lock?
An inertial lock for the, pop that for the back of that. So as you are, it's hinged way up here, and if you get into a crash event, there's nothing that really holds it down. There's a tiny little torsion spring in there, but there's enough force in an accident event that would pop up and keep your console door locked shut.
In an accident event, yes. I was wondering if somehow, since, no, this one is not. I was wondering if this was like a folding armrest, if that was part of a lock that when I lifted up, if it would fall and lock in place.
Entirely possible.
Well, it has too much spring force to do that unless we put too much spring tension on it when we put it back together.
So that engineers can have their own little arguments about what the function might be in any particular instance. And that's one of the fun things about what we do at Munro is when you're designing something, you know what you're designing for, but when we're taking it back apart, we make some very educated guesses, and I tell you what, this place, they're very educated guesses, but sometimes they are still just hypotheses about what an engineer may have designed a certain part or structure for. So coming over here to the panel.
So this is a trim side panel for the center console. Look at the material that this is made out of. This was actually made in several steps. This background material is a natural fiber reinforced, most likely polypropylene plastic. She is compression molded. These ribbings are then overmolded over top of this compression molded sheet. All right, what's the benefit of that? Why didn't you just mold a panel since you already had to pay for an injection mold that entire size to do all this ribbing? Well, it's because of lightweighting. Rib to wall ratio for any type of an injection molded plastic is a very important thing. Think about a cheap storage shelf or a $10 Tupperware bin. All of the ribbing that you'll see on those components sink. You can see lines from the A surface looking like some sort of a milk crate. We want to avoid that on anything interior in a vehicle. We want them to be nice and flat. So if this was a direct injection molded polypropylene plastic, we would say that these ribs can be no more than 40% of the thickness of the panel. That causes a lot of interior panels to be 2.5 or 3 millimeters thick, just because they know how big those ribs on the B-side need to be. But if I were to compression mold this panel here and then overmold the ribbing, I will have no sink. I will have no sink read through. I could very well make a compression molded panel that's 1 millimeter thick, 1.5 millimeter thick, and then put whatever structural ribbing I need. Which makes this very, very lightweight.
And not only that, when you're talking about this reinforced formed material, what you're seeing in there, and you can see the fine grain structure, is it's a natural material, which means that this is more green than if we made the entire part from this plastic. So using this natural material, and that can be, gosh, that can be anything from bamboo fibers to cork particles. There's all kinds of different plant material that's used in here.
10 years ago, when I was in a research group, my boss came over with a 5-pound bag of hemp and dropped it on my desk and said, "Separate my stems and seeds." And that was actually an important thing because you do want very consistent fiber size. You don't want anything that's big and chunky getting stuck in there and messing up how you're compression molding. But I thought that was hilarious when he did that.
That is pretty funny. So again, the fibers can be anything, but there's a lot of natural fiber that is grown specifically now for inclusion into panels like this. And again, reinforcing the reinforcement that causes sinks on an A surface. This is an issue for every plastic component in a vehicle. You have to either put on a substrate to reinforce behind the A surface that's separate, or you need to be really careful about controlling that 40% to thickness of surface ratio to avoid having a sink line that will look just like that hex pattern on the front side, or whatever your ribbing pattern is. You'll see those little lines, and it will absolutely read through your laminated on trim.
Yeah, if it is a foam wrap, fabric wrap, if it's a hard wrap, I have seen up to 3 millimeters of foam for a die cut foam have read through right even through that. And everyone assumes, well, if I'm wrapping it, I'm covering up that read through.
Oh, heck no.
No, it'll still read through.
So
This,
what the heck is this?
Get to that in a minute. This piece right here was exciting to me when the other members of the team pointed out that they had looked at what its material call-out was. This is a injection molded nylon part, but it is carbon fiber reinforced. Why would you do that? And that was a question that came up many years ago. I did my thesis for injection moldable carbon fiber. And in a sense, you would say, well, that's throwing pearls before swine. Why would you take something that is that expensive and just use it chopped up inside of an injection mold? There is a business case to be made for it. Now, normally you would use glass fiber, okay? Glass fiber is 2.7 grams per cubic centimeter. Carbon fiber is 1.7, so you have lightweight. That's good. Carbon fiber is also a smaller fiber size, diameter than glass fiber. So what is the fiber reinforcement actually doing? You have a plastic matrix that has a bunch of long chain polymers. That fiber in there acts as a lattice work, and all of those plastic polymers will grab onto that fiber, making a stronger part. Okay, well, if I have what most salespeople would say, well, if it's 30% by weight, 30% by weight of carbon fiber is too much. Your density, because it's much lower density, honestly, you don't want to do a direct weight per weight replacement between glass fiber and carbon fiber. You can go by volume. You're going to have a lot less weight, so you're saving money in the carbon fiber there. But not only by volume, since we know that that fiber is acting as a reinforcement with all of those polymers grabbing on, since you have an increased number of fibers per cubic centimeter, you actually have even more strength. So you can have a part that has equal properties to a 30% glass filled with a much lower carbon fiber fill content. I had some samples that, because the density of the polypropylene, which I was using, is like 0.9, it would float on water. We could really, really save weight. And I do believe that that was their goal here, was to save weight, because they have some very thin structure. I don't know if this was a test sample or if this is something that this company has been doing for quite a while. Because again, I have not looked into this since I wrote my thesis a dozen years ago. But I asked Sandy about it. I asked him if he had seen an injection moldable carbon fiber yet. And of course, all of the things that he can pull out of his hat, he gave me this. This is not from automotive, so that's probably why I did not know about it. This is actually a frame from a crossbow. And this is nylon injection molded with carbon fiber for reinforcement. Now, they kind of went ahead and gave a grain pattern that looked like woven carbon fiber, but that's just a grain in the injection mold. They just wanted to make it look pretty and high tech. It is just a chopped fiber reinforcement. So even though I did not know about this stuff when I was in automotive and researching it, apparently it's something that other people have been doing and doing with success. So I'm very, very happy to see something that I thought was a science project when I wrote my thesis that is making it into automotive.
It's come to fruition. Yeah, and again, just emphasizing that the changes in the automotive industry happen so rapidly, and you need to be up with the current industry trends, because this was not this same construction a couple of years ago. And we've seen that Tesla implements running changes throughout their vehicles with the latest technology. So each iteration of their vehicle has demonstrated advancing technology, and then they backfill through the rest of their vehicles with that same technology. I don't know that that's happened with this part, simply because carbon fiber is expensive. And in the Model S, again, you're paying for expensive and high quality. But again, that is what's been done in the Tesla model, the backfill of new technology.
Yeah, and not only is it expensive, but most carbon fiber, since it is those carbon fiber sheets, when they make carbon fiber, it is made from PAN, polyacrylonitrile. It's kind of burned off, leaving that carbon strand. That stuff is so light, so fluffy, that when they manufacture it, it can blow away. So they have to put on sizing, which is basically a little bit of the material that it will eventually go into onto those fibers just to hold them together. Because most people use them in those sheets, those are sized for epoxy. You cannot take that material and just chop it up and put it into this. You have to work with a carbon fiber source to use a sizing that will work with your thermoplastic or any other material. And I know back when I was doing it, that was the challenge, to find a supplier that would have chopped fiber that would work with, I was dealing with polypropylene. You can do it, you can do it. I don't know why, even today when I talk to people about it, they say, well, why would you do that? It's too expensive. Not if you think of it in the right way.
You know, there are other industries even that are using it that are not as advanced as automotive, including things like, say, fiberglass pools. There's chopped carbon fiber in there. There's even chopped Kevlar, which is an aramid fiber, which improves your abrasion resistance. So if you strategically place and use and locate those high-tech fibers, you can still make a cost-competitive product with enhanced strength, enhanced abrasion resistance, and not be a lot more expensive.
So I hope this was interesting for you. Yes, we have a nice decorative trim material, which is a high-end expensive trim, but that you could have on any vehicle. We have a very unique mechanism that functions fairly well. That's quite nice. We have materials that are not necessarily exotic, but not known to a lot of people, with a compression molded natural fiber panel, which gives you a great weight savings, carbon fiber reinforced structure. I hope you found this interesting. I hope you liked what we were able to put together. Again, all of this stuff will probably be dug into in even more detail into our reports. So from Munro Live, thank you very much for watching, and I hope you have a good day.
Thanks for joining us.